Hello friends, in today's lesson we're going to derive power series form for common functions. With that being said, let's dive in. For our first example, for our first function, we're going to have f of x equal to 1 over x. Now we want to find the power series representation for 1 over x. Now there is one thing we really need to know. For us to write this function, do a power series form, we need to put it in a form which will be equal to this form: a over 1 minus x. This is the form we need to put this function in, because when it is in this form we can just go ahead and use what we are going to have and write the power series form in this way. We're going to set n equal to 0 up to infinity, then we are going to get our number which is going to be there, which is our a, which is just the first term. We're going to write it here, then we are going to multiply it with the x. We're going to multiply it with the x, so x raised to the power n. So but before we solve that, I need to show you another form for this one. Let's say you are given a function f of x equal to a over 1 plus x. Now this function which we have, it has a plus, but the form which we really need to put, the form that we need to put the function in is that form. This is the form we are following. For you to write it into this power series form, you have to put it first into that form. So we are going to check. We check a goes together. Now over 1 and 1. So here always the number that must be there is 1. You can't have a 2, you can't have a 4, you can't have a 3, but only a 1. But here it can be over, it can be anything. So now where we need to focus our energy is about here, 1 and negative 1. So they always need for you to have a 1 and a negative 1 here. But everything here can change. Now how can you turn this positive into a negative? We all know the fact that positive is equivalent to negative multiplied by negative. We know that when you multiply two negatives, you're going to get a positive. So that is the fact that we are going to use. I'm going to say a all over 1 less negative x. So now you have to see this. You have to take cautious of this. For that one, when we had 1 minus x, we were just taking x as a positive. This one we had 1 plus x. We needed to find a way on how to make this sign which is affecting x to be what? A negative. We did say that negative multiplied by negative is still a positive. We did here. We did the same thing. So now check. We use the first term, it's a, and here x is positive. But for this case, what is our x? Our x is negative x. So the power series form here is going to be x, the sigma notation as n goes to 0, as to infinity. We're going to get our first term. Now our x is no longer just a positive, like in that. It will become what? Negative. So it is negative x to the power n. Now with this fact, I want to show you another thing which you need to know. We all know that when there is a, b powered to n, isn't it? It's the same as a to the power n multiplied by b to the power n. So this is the same fact on how we are going to allocate the n here. We all know that there is negative x to the power n. It has a coefficient of 1. So what I'm going to do is I'm going to allocate the n power to 1 and the n power to x. So it's going to be negative 1 to the power n multiplied by x to the power n. So our power series, this one, will now turn out to be sigma notation n goes to 0 up to infinity, a negative 1 to the power n x to the power n. So what we have here, ladies and gentlemen, is a power series for f of x a over 1 plus x. But what we have here, ladies and gentlemen, is the power series for a over 1 minus x. And this is a general form of which you want to put all your power series into a form when you are having functions like this. So now we have to find a way, or now we are going to turn this body into this form so that we can be able just to write it using this form. So that being said, let's now we concentrate on our question. So we know the form we are trying to put this boy into. It's a form where we have a over 1 minus x. Now a is a number. You don't have to find a there. Whatever number we are going to have on top, that will be your a. Let's go ahead and put this in this form. So now check. We need to have a 1 and a minus, which is going to affect this x. But now you can't just go ahead and introduce a 1 minus x like the way this form is. You have to find a way in which you are going to change this function into this form without changing the meaning. So first thing is first, I'm going to rewrite this function into this form. I'm going to rewrite it into this form. I'm going to say 1 over, I'm going to introduce 1 minus 1 plus x. I've introduced 1 minus 1 plus x. Now, you can all agree with me here to say that this function is still the same with that. Let me show you to say 1 minus 1 is still 0. 0 plus x is still x. So this is still the same as 1 over x. Still the same as 1 over x. Now, what we are required to do is now to change to have a negative to affect the x part. Because now if you come to think of it, you just see that this negative is just affecting a 1 and it's not affecting the x. So for the first part of our solution, we are going to say 1 on top, there's nothing which happens to it. We still have a 1 which is being maintained. I'm going to factor out a negative. So what I'm going to have, I'll have a negative. I'll have negative, this will be negative x. This will turn into what? It will turn into positive 1. This is what we have. This is what we have come to. But now check the way it is now, where we have reached. Yes, it still has the same meaning with that, but we have changed it a bit. Still has the same meaning with that, but we have changed it a bit. With all what we know, x was positive at the start, and this x always needs to be what? A positive. At our function which we are given, x was positive. We want to change it into a form which it will look like this, but don't changing what? The meaning. So how can we make this x here now to become a positive the way it was? That's a question we need to ask ourselves. Without changing anything, this part. For this side, we need not to change anything. We just need to find the way we are going to make this x a positive variable. So this is a way which you are going to make x positive. We're going to maintain everything, 1 minus. Then inside the bracket, I'm going to factor out the negative out. Inside the bracket, I'm going to introduce another bracket. This is going to be what? X. Then negative multiplied by, for us to have a positive here, when we multiply back, I have to introduce what? A negative 1 like this. I haven't changed the meaning. I'll say negative multiplied by x is negative x. Negative multiplied by negative, it's positive. Then 1 will be there. So now, the form which we have made here is in the same form like for this one. Now, what we have here, we can just go ahead and identify which one is our x and which one is our a. Then we're going to write it into the what? The power series form. So our a is equal to 1. And what is our x? Our x is the whole bracket. Because our x, it is what is being affected by this negative just after the 1. So our x is this negative x minus 1 like this. So now from there, let's just go ahead and write this into the power series form, which we all know and we all have. So this will turn out to be infinite. N goes to 0. Our a is 1. Our x is what? Negative x minus 1 to the power what? To the power n. Now remember what I said. Whenever you just see a negative here, just know that you are factoring out a what? A negative 1. So this will all end up to be, if n goes to 0, approaching infinite, this one is negligible because it doesn't affect anything. Negative 1 to the power n, x minus 1 to the power to the power n. Ladies and gentlemen, this what we have here is the power series form for the function 1 over x. 1 over x. This what we have here is the power series for a1 minus x, which is the fundamental function which we use for us to find all the power series. Then this is another example of a over 1 plus x, of which we need to convert it to be in that form for us to come up with this power series which we have come up with here. Ladies and gentlemen, thank you for watching. If you haven't yet subscribed to the channel, hit on that bell icon so that you don't miss out on future endeavors. Bye bye.